Okay, today I'm going to make ammonium perchlorate composite propellant, also known as rocket fuel. I have here 3 micron aluminum powder, atomized, which is important. I have copper oxide, and I have 90 micron ammonium perchlorate. So this will probably be a fairly long video. I'm using silicone 2 as my binder. And I'll go ahead and basically, I guess, just get started, if I can set the camera down properly. Okay. Let me make sure that everything's in order. Okay. So I've gone through a couple of formulas in the past, which I do not have with me right now. Gonna go get that. A recipe that I tried before that had a pretty good burn characteristic, and basically just like I said, I'm just gonna double it. So I'm gonna go ahead and throw some gloves on. And get started. So the recipe, since it's going to be doubled, calls for 70 grams of ammonium perchlorate, and I'm going to have probably around a 30 gram excess, probably around 40 gram excess, which I should probably do something with. I'll figure that out when the time comes. So let's go ahead and get started here. I'm going to weigh out the ammonium perchlorate first, and pour it into a plastic bag very carefully. I'm going to then knead it so that there are no clumps. As you can see, there are a fair amount of clumps in this, so I'm going to go ahead and do that. So I need 70 grams of ammonium perchlorate. $69.9, 70.1 grams of ammonium perchlorate. Okay, I no longer need the ammonium perchlorate, so I'm going to set that to the side. And I'm going to take the ammonium perchlorate, dump it into this here plastic bag carefully. I'm going to close up the plastic bag, and I'm going to knead it as finely as I possibly can. So this can be as simple as just feeling around, breaking up the larger clumps. Then I'm going to go in and lay it down and press it through. The reason I'm doing this is because in the final product, you want absolutely no clumps of ammonium perchlorate, because it will create an uneven burn rate in areas. So it needs to be very fine and well dispersed, evenly dispersed. So whenever I put in the aluminum powder, in the copper oxide, I'm going to be a lot more careful about this than I am right now, and that takes a considerable amount of time mixing it, just because of the care required. So, it's looking alright, kind of. And I'm going to go ahead and call that good enough as of right now. So next I need 5 grams of aluminum powder and 1.8 grams of copper oxide. So I'm going to go ahead and open up the aluminum. I should probably have a particle mask on, but this is kind of a quick mix, so I'm just going to go ahead and do it. Alright, so I've got a spoon here, and I'm going to start off with the aluminum and then move over to the copper oxide, since the aluminum is lower density and shouldn't contaminate the copper oxide too much. So alright, that's 4.3. 4.5, 4.8, 4.9, 5.0. Okay, and while that is still on, I'm going to very carefully try and measure out 1.8 grams. So I'm going to tare this. 1.0, 1.1, 1.4, 1.5, 1.7. Oops, tiny bit too much. Okay, so, ooh, sugar. Okay, that's a problem. And this gets to go in the trash can, because I just mixed the aluminum and copper oxide. So I'm gonna hope and pray that that's not gonna mix any more than it is. What a waste. That's sad. Okay. Always make sure that if you have an excess of chemicals that you put them back into the correct bag. Okay, so now I have my fuel and my oxidizer weighed out. So I'm going to very carefully now, emphasis on as carefully as possible, mix them, which is, typically speaking, a massive no-no. So I'm breaking the rules. Okay, I have a pair of long needle nose pliers in here somewhere that I'm going to use to shake this around. So in the event that it blows up, it will not be attached to my body. So the ammonium perchlorate's already forming chunks again. Not good. It's probably due to the humidity in the surroundings right now. ammonium perchlorate has to get ground down. So very carefully, at a slight distance, going to try and smooth it all out without blowing myself up. If I'm correct, this mixture should not technically be considered a flash powder because of the low percentages of fuel versus oxidizer. However, I have never burnt test this, so I could very well be wrong, and I'm actually going to try a burn test here in a minute, give you an idea, and myself an idea. Okay, so it's starting to look alright, but this is what I'm talking about when I say that it needs to be finely, done. So the ammonium perchlorate, you can tell whenever I slide this past, it spreads out and the clumps break apart. So have to make sure that all the ammonium perchlorate is separated from itself. So, going to continue. Should look like a completely homogeneous mixture. This is a mega no-no, touching the mixed powdered fuel and oxidizer. If this blew up right now, it would easily take off my hand. Okay, I'm going to call that as complete as possible, and I'm now going to mix in the silicone binder. So I'm going to take a small amount out to perform a flash test, just to see how stupid of an idea that was. I'm going to try and keep it down to a minimal amount, separate it to the side, and then I'm going to put in my silicone binder. So recipe at this point calls for 24 grams of silicone. So I can kind of be liberal with it because it's going to take a good bit of silicone to get up to that amount. 23.2. Okay, that's not a huge problem, but slightly undesirable. 23.3. Okay. The downside is that the burn rate might be decreased by getting that much silicone in there. So I'm going to carefully try and take some out. 23.1. Okay, 23.2. I'm going to try and take a little bit more out. Okay. 22.7. Okay, so that's slightly under the 23. That's okay, because oxidizer rich is not a bad thing. So I'm going to move the gram scale to the side and very carefully begin stirring with something that I could probably actually start with. So I'm going to first start by coating the silicone, if possible. It's a sticky mess, so manipulating it with the hands this early would be a mistake. Because it'll just stick to the gloves. So basically I'm just kneading it as if it were dough, and every time the silicone gets pressed, a wet surface gets exposed, so the powder sticks to it. I mean, I guess technically speaking, this propellant is relatively safe. It's not shock sensitive as far as I know, although it is static sensitive, if I'm remembering correctly. So definitely trying to be as careful as I can. Okay, so now something good is starting to happen. As I stir it up a little bit faster, the silicone is starting to break up into smaller chunks, which is good, because as it breaks up into smaller chunks, the surface area of it increases and more of it gets into contact with the powder. So it's still too early to manipulate with the hands, but soon I will be able to manipulate it just like Play-Doh. And as I work the silicone fuel, it becomes almost wet as you work with it, and then you use that wetness to pick up more fuel. Okay, so it's getting close. This does kind of stink. So right now I'm just flipping it over, pressing it back down, flipping it over again, pressing it back down. What this is doing is not allowing enough time, hopefully, for the silicone to start sticking to me, but giving it enough time after pressing it that it will pick up the powdered fuel and oxidizer. I also want to try and clean off the spoon if possible, because that contains a fairly large amount of the silicone as well. So press, grab, flip, press, pick up, flip. Pretty good consistency right now, but I know that that's not a permanent thing. Okay, now manipulating it a little bit more than I was before, just kind of kneading it. And as I do that, the entire surface becomes wet, moist. You can hear it sticking to the glove. So press it back down into the powder, do the same on the other side, spread it thin if you can, pick it back up, flip it over, do the same thing, pick it back up, manipulate it a little bit more. Try and use it to get some of the silicone off the spoon or whatever you're using to mix. Should have used a bigger bowl. This is the largest batch I've ever made, so not planning on it taking up this much space. Okay, so pretty much by now the hazard of explosion is completely gone. Although the hazard of ignition is still there, because this fuel is very strong. I've worked with potassium nitrate and sugar fuels before, a long time ago, and just to put it into comparison, this is much, much stronger, it seems. Although the flame on a potassium nitrate and sugar fuel, when ignited in open air, does look pretty intense, even though the majority of it is just smoke. So I've almost got the spoon clean now, which is good. Okay, so now I can get rid of the spoon and just work it. You need to make sure that you measure out all of the ingredients properly beforehand, because first of all, I've never tried to mix in new ingredients afterwards, but I can't imagine that it would do so well. Just because working in a new consistency into this would be rather difficult. But I must say I might be giving it a try today. So right now, looks like I'm just playing with it, but I'm trying to squeeze all the inside up to the outside, and the outside into the inside, and vice versa. Okay, so we've almost got all the fuel taken up. I probably should have left a little bit more of the silicone in than I did. I have a feeling I'll be able to make it work. I've measured the density on this mix, and it came out to 0.061 pounds per cubic inch, which is really good in terms of ammonium perchlorate propellants. Usually they can be anywhere from 0.55 to around 0.055 to 0.066. So this is right in between, which is excellent. And the denser your fuel is, technically speaking, you can get a higher ISP per unit density, and it obviously occupies less volume. So you might get a greater total impulse using a higher density fuel. So, okay, so this is all the powder's been worked into it now, and the outsides are crumbly for the most part, which is bad. So trying to keep all the things that are crumbling off falling back into the bowl so I can pick them up in a minute. So I'm going to split it up, kind of mash it around, just work it. Try and pick up some of the fuel that's stuck onto the gloves. Okay, so now it's got okay manipulation. First batch I made was very difficult to manipulate. I used only 22% silicone by weight. This one is 5% aluminum, 1.8% copper oxide, 70% ammonium perchlorate, and 24% silicone 2. So now it's starting to work into a good manipulation, and the silicone is huge in making that happen. The silicone minimum percentage, I would say, is probably 22%. That's probably the lowest you can go with these kinds of mixes. So. Now I need to kind of act fast because it does start trying to get ready to crumble pretty quickly. So what I'm going to do now is try and press it into a fuel grain. So I made an excess, and I'm going to try and roll this into a ball as best I can. And then smooth it out. Okay. So now, I'm going to try and get it to fit into this thing, because this will hopefully be in a rocket motor within the next couple days. So I'm going to slide this in as best I can. Line it up straight. Ironically, I get to use a nickel to press this. The diameter happened to be almost perfect. And I have a feeling I'm never going to get this nickel back, am I? Just press slow. To let it get lost. Probably should have split this up into a couple of propellant presses. I'm not going to try and complain just yet. Oh wow. Okay. Parchment paper is a good idea, people. Nickel is trying to come out. Okay. Hey, look, I got my nickel back. Tee-hee. Okay. Okay, now what I'm going to do, actually what I should have done the first time, is tear a tiny bit of this parchment paper and use that whenever I'm pressing in the rest of the fuel. So I only need a tiny bit more. That might be too much. Let's go with half that amount. Okay, so I'm going to go ahead and lay down this parchment paper first, and then press in like that. Applying force now. Carefully remove from the parchment paper, and carefully remove that from the grain. Okay, it's a little messy, but it's showing promise, so I can put in just a tiny bit more. Okay, it's definitely messy. That's not a problem that can't be fixed. So I'm just going to take a little bit of extra propellant and press it in with my finger here. And try your best to keep it clean, because the cleaner it is, the better. Okay, so the big question will be whether or not this actually fits with the nozzle on it and all. But all in all, looks like a good grain. It's going to bond to the walls, and then from there I will clean it up. Okay, let you get a good look at this. Okay, so this is the part that was not pressed. This was the part facing down. So this will be the top of the motor. And even though there's a little bit of air spacing, that's fine. This is the bottom side. And this is just a propellant casting tube. So basically, all this is doing is just holding the propellant. This is not my motor by any means. Okay, so now I'm going to take the rest of the propellant and mash it up. Probably do something smart with it if I can. Probably not. Nothing smart gonna happen here. Okay. So knead it all together. It's pretty good consistency. Get all the crap off my gloves. I'm gonna roll it into a ball and then probably just make a long grain out of it, I guess, and then maybe I can cut it up later. Or maybe put it in something, make a propellant strand, who knows. I don't know. One thing I will say, you should always use a press when you're going to make a motor grain, because whenever I mix these things by hand like this, there are microscopic little gaps that always, for some reason, end up getting taken advantage of by the flame, and then you have an exploding grain on your hands, which is no good. So I'm going to do, I guess, a propellant burn test in a minute, and probably only use like half of this maybe, and allow the other half to cure. So I'm going to very carefully twist and hope this breaks cleanly, and it's not at all. Okay, that's fine. And the consistency of this stuff is really good whenever it's dry, because it's pretty much the equivalent of what it normally feels like, I guess, eraser something, so it's definitely good. Alright, And before the video is out, we're just going to see how incredibly dangerous it is mixing propellants beforehand. I'm going to use a laser for ignition. And let me just see where the focal spot is. I'm going to dial it down a tiny bit. Okay. So I'm going to take us outside. Hopefully this will not blow up in my face too badly. So I'm just going to set it, I guess, right here on this leaf. This leaf. Okay. Okay. So I'm going to ignite it via laser. And very carefully. Okay. Cool. Not hand blowing off action. Excellent. Smells like hydrochloric acid though. Okay. Thanks for watching. Bye.